Greetings everybody, and today we're going to be taking a look at the 2021 Specialist Maths Exam 2. So this video is a little bit overdue. I was supposed to film this like a couple weeks ago when they released this, but yeah, got too lazy, don't have enough time and whatnot. I have taken a quick look through this exam though. I've done the multiple choice questions and like I think half of section B questions. I haven't touched the last like 3 of them, I think. They do look quite annoying though. Like, look at that whole paragraph you got to dissect. Yeah, glad I didn't do this exam I guess last year. I did it in 2020 because yeah, I only got a 34 in English, and yeah, I don't like reading paragraphs of stuff and whatnot. Anyways, let's just jump straight into this. The solutions. We're only going to be doing the multiple choice questions, of course, because I haven't done the whole exam yet. I could do it, but I'll probably make mistakes and whatnot. So first things first, what I'll do is I'll define I to be the imaginary unit, just so I save 2 keystrokes. That's something you can do instead of pressing pi and then enter and whatnot. You could just type in I if you predefine it on your CAS before the exam. So let's take a look at the first question. We're trying to find the number of asymptotes that the graph f, which is this reciprocal of a set graph, has on this interval. Now, this function won't have any horizontal asymptotes because our set graph is always periodic. It's going up and then down and up and down. So it's not going to decay out to something. So no horizontal asymptotes. It's only going to have vertical asymptotes, which are going to happen when the denominator is equal to 0. So what we have to do is we can, for example, use the zeros command or the solve command. It really doesn't quite matter. And we'll put in the sec of 3x. Plus 3 over 2 with respects to x, and we want the domain as well, which is minus pi on 6 less than or equal to x less than or equal to pi. So let's approximate that, and we get 3 solutions. So the answer is B. Question 2, the implied domain of the function, this inverse cos of log. So that's pretty easy. You just type in domain on the CAS. That gives you the maximal domain. So we got r cos or cos inverse of the natural log ln of b times x. Remember that multiplication sign, that otherwise bx is treated like one variable. And then comma x, and then that's something. Now we also need b greater than 0. So as you can see, there's 2 cases. So we have some set of inequalities or some set of inequalities, and we want the one where b is greater than 0. So this is 1 over e times b and then e over b. So that's going to be option E. Question 3. The coordinates of the local maxima of this graph. So this is a reciprocal of some looking like some quadratic in a cosine or something like that. So how do we maximize this function? Well, this is a reciprocal, so we would like to minimize this denominator. Now, how on earth do we minimize this denominator? Well, it's not too tricky to do. This 3 is constant, so we want to minimize this squared part. So what's the smallest a squared term can be? Well, it's going to be equal to 0. For example, cosine of 8 times x, that could be equal to minus 1, and minus 1 plus 1 is 0. You can't have this whole entire squared part here to be negative because, yeah, the quadratic on the x squared function is always positive. So what we really want to do is we want to find where cosine of a times x is equal to minus 1. So what is that going to look like? Well, we want to solve for where cosine of a times x is equal to minus 1, and with respect to x, let's see what that gives us. So we got 2 times n7, so that's this integer, I guess. So this is an odd integer overall, 2n minus 1. So an odd integer multiple of pi over a. So where's an odd integer multiple of pi over a? Well, we got a sum right over here and here, d and e. C wouldn't be 1 because that's an odd integer multiple of pi over 2a, which is not what we want. And then the others are just, I think that's just integer multiples or something. The question is now, is it d or e? So that's the side from these y coordinates. Now remember, this guy over here, that can be equal to 0. So when that is equal to 0, we're left with a third. And that's going to be the maximum, so it has to be e. And of course, a quarter is less than a third, so that's not the maximum. So question 4, z is a complex number. Imaginary part of z is greater than 0. Arg of this conjugate mess. What is that? Well, whenever you're dealing with conjugates, a nice thing you can do is define, for example, z to be equal to a plus bi, or b times I actually. Now what we can do is, for arg, you can just type in angle. Now angle, that's basically the arg, it's the principal arguments on the cas, so between minus pi and pi. So what we can do is arg of, we have a fraction of z times the conjugate of z over z minus conjugate of z. What does that give us? We have a sine, minus sine of b pi over 2. Now, what on earth is sine over here? S-I-G-N. Well, that's this positive if b is positive, and it's negative if b is a negative number. So in this case, we want the imaginary part to be greater than 0, in other words positive, which means the sine of b, which is our imaginary part, that's going to be positive. So overall, that's minus pi on 2. If you want, you could also specify that, for example, such that b is greater than 0, something like that, and then you'll get minus pi on 2 as expected. So option A. Question 5. So we want to find the maximum value of the modulus of z. So we're on the circle. Modulus of z, that's just the distance between some point on the circle and the origin. So how do we maximize that? Well, what we could do, well, the only way to maximize it is if you draw kind of like a line through over here. You can tell that I've tried to record this previously, and yeah, I kind of messed things up a little bit, so I'm pre-recording it now because the ruler is in the exact perfect orientation, I guess. So you can draw a line through the, what would that be, the center of the circle, and then you add on a 1 over here. So the question is, what is the distance between 0 and the center of the circle? That's not too tricky to figure out. It's just the absolute value of, well, the center of the circle is 2 plus 3i. That's going to be, no, sorry, not 3i, root 3i. So square root of 3i, that's root 7. And then you add on this extra 1. So that point's right over there. That's the furthest away from the origin. So it's got to be square root of 7 plus 1. So option D. All right, question 6. So z is a, let's get rid of this ruler. Z is a complex number, z is not 0, z squared is a real number, then the possible values for arg z are. Now, z is a complex number, okay, and z squared is a real number. So if you imagine the complex plane over here, what happens when you square things? Well, first of all, the modulus gets squared, but also the angle doubles. So what are the complex numbers such that when you double the angle, you land back on the real axis? So the real axis is where you want to be, right over there. So a real number, when you square it, of course it lands back on the real axis. So you could have arg z being equal to, for example, minus pi, or sorry, not minus pi, 0 or pi. So it could be over here, or it could be over here on the real axis, positive or negative. If you square it, you're still back on the real line. Now, what other possibilities are there? Well, if you're purely imaginary, which means if you're purely on the imaginary axis, well, if you square things over here, well, your angle also doubles. So you're going to land on the real axis once again. So in fact, and yeah, any other number, let's say over here, if you square it, that's not going to land back on the real axis. So you only want integer multiples of, well, this is pi on 2 over here, square angles or whatever that's called. So it's option A. So the only numbers that satisfy this are the red line or the green line. All right. I don't know why they excluded z equals 0 because, oh yeah, that's right, arg z, that's arg of 0 is undefined. That's why they removed 0. So question 7, a relation is defined parametrically by these set of parametric equations. Okay, now you could probably tell that this is a circle because we have a cosine and a sine. I think that's the frequency or something. I don't even know what it's called. Yeah, that's constant multiplying in there is the same, it's 2. And then this 5 over here, that's the radius of the circle. And the center of the circle, that's going to be 1, minus 1. So if we do a quick plot of this, where we have the center at 1, minus 1, and then we want to go out to the sides by 5 units each. So if this is if this is 1, minus 1, then we can go for example, out this way, or we could go up this way 5 units, and that should land us at these points A and B over here. So if you go up 5 units, well, the x coordinate is the same, it's 1, and then if we add that's going to be 5 to -1, that's going to be 4, and then if you do the same for this guy over here, that's going to be 6 minus 1. So the circle has a radius of 5, so the circle is going to look something like this, probably. That's a horrible circle, but yeah, you get the idea. We'll just draw a segment of the circle. Now, so these points are definitely on the relation. Question is, what's the shortest distance along the graph from A to B? Well, it's just the arc length over here. Now, what's the angle subtended? It's pi over 2. And to find arc length, you just multiply the angle by the radius. So 5 times pi over 2, that's option E. Question 8, we got some Euler's method over here. So we can just go to our CAS. I'm going to use the Euler's method program. So I'm using my CAS programs as well. So you can check out my CAS programs if you go to my website as well, if that's something you're interested in. Otherwise, you can just do this using the usual formulas and whatnot. So we'll go to specialist and differential equations and Euler's method. So we're going to chuck in our dy dx, which is y times sine of x. X starting value is 1, y starts is 2, x ends, I think that's like 1 point something, 1.2, and step size is 0.1. So when x is equal to 1.2, y is equal to 2.3615, which rounds up to 2.362. Oops. So it's option C. Question 9. Which one of the following derivatives corresponds to a graph of f that has no points of inflection? Okay, if I can remember how to do this. So notice we have some quadratics and some cubics. Now, we'll use a fact that all cubics have points of inflections. So if these are derivatives over here, notice we have some quadratics. So this one's a quadratic, this one's a quadratic, and this one's a quadratic. If you integrate a quadratic or anti-diff it, you'll get a cubic. So cubics are going to have points of inflections. We want a function f that has no points of inflection. So a, c, and d are automatically gone, which leaves us with b or e. So how do you determine if a function has points of inflection? Well, there's this factor, or it was a point of inflection. If you want a point of inflection, then f double prime, the second derivative, changes sign. Now, in this case, we want no point of inflection, which means f double prime doesn't change sign. So the question is now, for these f primes over here, what is the corresponding f double prime? And we want to select the one that doesn't change sign. So for option B, the corresponding f double prime, that's going to be something like 6 and then x minus 3 squared. And option E, that's going to be something like 3, x minus 3 squared, and then minus 12. Okay, now notice these are both in turning point form. That's good because we know what it looks like. So for option E over here, the turning point is 3 minus 12, so somewhere down here. And then, yeah, it's a positive quadratic, so it's going to go up something like this, probably. And as you can see, this is not very good because there's a change in sign at 2 different spots. So in fact, for E, the corresponding graph of f, it's going to have 2 points of inflection. Now, if you take a look at B, f double prime, that's just a 6x minus 3 squared. That's simply a translation of your standard parabola with an extra dilation, but that doesn't really matter. So it's going to look something like this. Now over here, this is good. Even though we touched the x-axis, we don't change sign, which means B is the answer. So if the second derivative doesn't change sign, which is what happens with B, then we have no points of inflection. So that's perfect. All right, so question 10. The differential equation that has the diagram above as its direction field is, well, something. So we want to, the best way to probably do this is just to plug in random points and see which ones match up nicely. Now you could plug in 0, 0. In this case, it's not very helpful because if you plug in zeros, then you're just going to get 0, but at the origin, it's clearly 0, so that doesn't help. So you could try plug in, let's say 1, 0. Let's see what that gives us. So 1, 0. Okay, so for A, so first of all, we want a negative slope there. So for A, if you plug in 1, 0, so x equals 1, y equals 0, then you're going to get positive. So this is bad because we want a negative gradient. For B, that's going to be positive once again, so that's not good. For C, that's going to give us -1, which is good. It's a potential candidate. For D, that's going to be, well, y 0. So this is possible as well. And for E, that is going to be positive. So this is bad. Okay, so we've reduced our options down to C or D. Now, what's another point we could plug in? For example, we could put in 0, 1. I think the problem with doing that, though, is that both of these are going to be positive. Both of them are going to be positive if you plug in 0, 1. So that's not going to reduce our options. You want one that kind of distinguishes these two, one that's going to be positive, one that's going to be negative. So let's plug in 1, 1. Let's see what happens there. So if you plug in 1, 1, then for option C, you're going to get something that's positive. Yes, because 2 times 1 minus 1 is positive, and for D, it's negative. And what's the slope at 1, 1? It's going to be negative. So we're going to select option D because that matches up. All right, question 11. What do we have over here? We have I as a unit vector and so on. And we want to find the position vector of A so what's happening over here, let's draw up a little picture. We're going to start at the origin and we're going to go down 5 kilometers south, 30 degrees west. Like so, and then we're going to go up, so this is 5, and then we're going to go up 10 kilometers. All right, so we want to find this vector over here, the vector sum. So how do we do that? Well, let's decompose this first vector into components. So for this first vector, we're going to, what is it in components? Well, we're going to have well, what's the x component? Well, x down here, if you imagine that it's the opposite side, so we're going to have a 5, and then opposite, that's going to be sine of 30 degrees, which is pi on 6. And then this is going to be negative as well because we're in the negative quadrants. And then the y is going to be 5 times the cosine of pi on 6. And then this is also going to be negative because we're in the third quadrant. And so that's the first vector, and then we add on the second vector, which is 0, 10. So, what is that going to be? That looks like B or E, so I think that's B. All right, question 12. Consider these vectors. So we have vectors over here, and theta is the angle between A and B, phi is the angle between B and C. We want to compute cosine of theta, cosine of phi. So how do I do this? You could write out the formula. So there was that relationship between cosine and the dot product and all that. So cosine theta, oops, I don't know why I keep zooming out. So cosine theta, cosine phi, what is that going to be? Well, cosine theta, that's the angle between, that's the thing with vectors A and B. So we're going to have A dot B over magnitude of A, magnitude of B, and then times B dot C over magnitude of B, magnitude of C. So what is that going to give us? Well, what is A dot B? That's going to be x minus 1, I think. Yes, x minus 1. And B dot C, that's going to be 1 minus x, like so. What is the size of A? Well, that's going to be the square root of x squared plus 1, just Pythagoras there. The size of B, I could write this as I shouldn't be saying size, I should be saying magnitude or something. What's the magnitude of B squared? Well, it's going to be 1 squared plus negative 1 squared, which is 2. So we have a 2 down here. And then the magnitude of C, that's going to be square root of x squared plus 1, once again. So overall, what is this going to give us? We have a negative over here. If we factor out negative from here, and then we have x minus 1 squared divided by 2, and then x squared plus 1, because those square roots cancel. So what is this going to give us? We're going to get d. Is it d? Yes, I think it is d. Should be d. Alright, question 13. Let's see what we got. Scalar resolute of a vector A in the direction of v is minus 4. B is some vector. So A, it's also going to be, so B is purely in the I direction. So the vector resolute is also going to be purely in the I direction. Now, what does the scalar resolute tell you? The scalar resolute tells you the size. So if you imagine your vector B pointing this way along the I direction, so this is minus root 3, or just B, I guess. Well, A, the scalar resolute is minus 4. And what this minus tells you is that it's in the opposite direction to B, and it also has a size of 4. So it's going to be acting in the other direction, so it should be E. So yeah, the size of the scalar resolute tells you the size of the vector, and yeah, this negative just tells you you're in the opposite direction of B. So that's 13. Question 14, we have a body of mass 5 kilograms acted on by a net force of F newtons. We have some relationship between velocity and displacement here, and we want to find F when x equals 2. So, to find F, we need mass times acceleration. Now, how do we get acceleration? Well, we got something over here that might help. So I think we can do, well, we can use A equals, I think it was, what was it, V dV dx. So V we got, and dV dx we can find because we have a relationship between V and x. So let's see what this gives us. So this is equal to M, which is, what is M? It's 5. V is 3 plus 2x. And then dV dx, that's just going to be 2. So at x equals 2, so we're going to plug 2 into here. We're going to get 5 times, this is 7 overall. So 5 times 7, that's 35 times 2, that's going to give us 70. All right, question 15. The diagram below shows a stationary body being acted on by 4 forces. They're in newtons. So the force of magnitude F1 acts in the opposite direction to the force of 8 newtons, okay. All right, so how do we do this over here? Well, first of all, we could, so this is in equilibrium, so we could resolve the vertical forces because there's only 2 of them. So F2, it has to balance out this 6 down here. So what's the resultant force acting in just purely the vertical direction over here, this red arrow? Well, it's going to be 6. And then what's the angle? Well, the angle right in here, that's going to be 60 degrees. So that's going to be 6 cosine, because we're adjacent, of 60 degrees, which is pi on 3. Now this must match up with F2, but then we multiply by, well, if we draw a little arrow up over here, that's going to be, we could draw it over here as well if we want, that's going to be the opposite, so sine of 60. So sine of pi on 3. And we want to solve this for F2. So solve this guy for F2. That gives us F2 equals 2 square root of 3. So we know what the size of F2 is, or the magnitude of F2. Now we can resolve along the horizontal direction. So we got F1 plus the components in the horizontal direction of the 6 Newton force, and then that should match the horizontal component of that F2. So we're going to solve now for F1. So solve F1 plus this green arrow on the left, that's going to be 6 times the cosine of 30. So cosine of pi on 6. And then this must be equal to the green arrow on the right. So that's going to be F2, which we found to be 2 square root of 3. And that's the adjacent, so that's cosine of 60, which is pi on 3. Let's solve this for F1. And that gives us -2. I think we are missing something, because that wasn't the answer I got before. Oh, we are missing that 8. I forgot about that. So should have had an extra 8 up here. So +8. There we go. That looks more like it. So 8 minus 2√3. Yeah, that would have been a bit weird though, because yeah, then we would be negative, which is strange, and that's not on the options. So yeah, make sure you account for all your forces. So question 16, we've got an object of mass m kilos, slides down a smooth slope. So let's draw up a little picture. So this is some theta mass, m kilograms, and theta is between 0 and 45, and the acceleration of the object down the slope is a. So we can draw out a little diagram over here. So this is mg, we've got some other arrows acting here. This is theta, and this is mg, that's sine of theta. So we know that's force equals mass times acceleration must be equal to just this force. That's the only force that's giving this block motion. So that's going to be mg sine of theta. So this tells us that A must be equal to g sine theta. So that's the acceleration. Now what happens to the acceleration when we double the angle? So let's see what happens when we do that. So we've got g sine 2 theta. But that's equal to g, using the double angle rule, that's g sine theta cos theta. But g sine theta, we know what that is, that's 2a. The question is now, what is cosine of theta? Well, we know this relationship over here. Well, we know cosine of theta, since the angle is between 0 and 45, we can write this as square root of 1 minus sine squared theta. Now, what is sine of theta? We can use this relationship over here, which gives us sine theta is equal to a over g. So this is equal to 2a square root of 1 minus a squared over g squared. Okay, now we can turn this one into, say, g squared over g squared, and this becomes 2a. Factoring out the g squared from the denominator in that square root just gives us g, and then we have square root of g squared minus a squared. My handwriting looks absolutely terrible. It usually doesn't look like this. I think it's because I'm so zoomed out, because I have the split screen over here, it's hard to write finally. Yeah, question 17, what do we have? Bottles of a particular brand of soft drinks are labeled as having volumes of 1.25 liters. The machine filling the bottles deliver a volume that is normally distributed. Have this mean over here and a standard deviation of this. What is the probability that 6 bottles have a mean volume that is less than 1.25? So the mean is, well, we've got the mean and standard deviation. This is just normal distribution. So let's go to our library over here, probability. We'll go to normal. And what do we have over here? Well, this is, we want to find, what's the probability we want to find? We want to find the probability that 6 bottles have a mean volume that is at least the labeled volume. So this is x greater than something. So this is option 1. The mean is 1.26. Standard deviation of the population is 0.01. Sample size, that's going to be 6. And the A value is 1.25. So 0.9928. Option E. Question 18. A scientist investigates the distribution of the masses of fish in a river. Here's a 95% confidence interval for 100 fish, and we want to find the sample mean. Okay. So from this, if you want to find sample mean, then what you need to know is the margin of error, as well as, well, this is a sample mean divided by the population standard deviation. So from this confidence interval, you can deduce 2 things: margin of error, as well as sample mean. So these you can deduce, and you need to figure out what standard deviation is. Now, to find what standard deviation is, you need to know precisely these 2 things. So you could use the formula for that. So margin of error is equal to, or just m in this case, margin of error, that's equal to, well, 95% confidence interval, so this is 1.96. And then we have sigma divided by the square root of n. So this is a formula you could use, so you could find sigma from here. Sigma is going to be equal to m square root of n, which is 100, so that's just going to be 10m divided by 1.96. So margin of error, that's not too tricky to figure out. You just got to take the mean of the endpoints, so that's going to be 70.2 plus 75.8, and all of this is divided by 2. So that's going to give you something, and then you subtract that from 75.8, and that's going to give you the distance from the middle to the endpoint, which is 2.8. So standard deviation is going to be equal to 10 times this value divided by 1.96. That's the standard deviation, and we want to find the sample mean. What's the sample mean? It's just the middle of this confidence interval. Here it is. That's the middle. That's the mean. And we want to find this divided by the standard deviation, which is this guy right over here. So that's 5.11. So that's closest to C. All right, so question 19. What do we have? The mean unscaled score for a certain assessment task. That's going to be 25, and the variance is 36. Now the scores are scaled so that the mean is 30 and the variance is 49. Now the scaling function takes this linear form. Okay, so we know what the scaled scores are as well as what the original scores are. So we know S is equal to mx plus n. So E of S, what is E of S? Well, we want E of S to be equal to 30. So 30 is equal to this guy, and this must be equal to E of mx plus n, but we can use linearity of the expected value operator. So this is m E of x and then plus n, but this is just m times expected value, which is 25, and then plus n. So we've got 30 is equal to 25m plus n. Now, as for the variance, we want the variance, or the original, well, we want the variance to be 49. So this is equal to var of s. And what is this? This is var of mx plus n, but we can use that property for the variance, so that's going to become m squared var of x, and then n disappears. And then what is this? This is m squared times var of x, which is 36. So we got m squared, which is 49 divided by 36. So this tells us that m must be equal to 7/6. So that's m. So if we just plug it back in over here just to find n, so let's just solve for 30 is equal to m, but we know what m is, it's 7/6 times 25, and then plus n, and solve that for n, and that gives us 5/6. So we know what n is equal to 5/6. Now, then what would a score of 32 be scaled to? Well, we just need to plug 32 into here, into this formula. And that's going to give us the corresponding S. So we got S, or let's just write m times x, and then we have plus n, such that n is equal to this, and m is equal to, what was m? It was 7/6. And then x is equal to, what was x? It was 32. So 229/6, roughly 38 point something, so that's 38. That is a lot of work for one question. No clue how you're supposed to do that in like 1.5 minutes or even 2 minutes. Question 20, an office has 2 coffee machines independent of each other. So these coffee machines have the same distribution, so both 30 seconds mean and standard deviation of 5. Now, on a particular morning, a cup of coffee is produced from each machine. The probability that the time taken by each coffee machine to produce one cup of coffee will differ by less than 3 seconds is equal to. So let's call it, I don't know, A and B or something for the two coffee machines. So these are both normally distributed with mean of, 30 and standard deviation of 5. So we want to find the probability that these two are within 3 seconds of each other. So A minus B in absolute values is less than 3. So this is equal to the probability. Now if A and B are less than 3, then we can write this as minus 3 is less than A minus B is less than 3. Okay, so this is some new random variable now. So let's call it C. So C is going to be normally distributed. So the mean of A minus B, that's just the mean of A minus the mean of B, they both have the same mean, so it's going to be 0. As for the standard deviation, it's not going to be too straightforward. So the standard deviation of C is going to be equal to, well, that's the square root of the variance of C, but that's the square root of the variance. C is A minus B, so that's the square root of variance of A. And then since there's a negative here, you have to square the negative, so that's going to be a plus variance of B. But variance of A, that's just the standard deviation squared of A plus the standard deviation squared of B. So we know what the standard deviation of A and B are. They are both 5. So let's plug this into the formula. So this is the square root of 5 squared plus 5 squared. That's the square root of, I think that's 50. What is the square root of 50? Well, it's something probably. Yeah, something. So let's use the normal program. So we're going to go down to probability. We got normal distribution, and let's run this program. So we want this to be between two values. So option 2, the mean is 0. So mean of C is 0, and the standard deviation is the square root of 50. The sample size, now we're just doing 1 over here. This is just normal probability unless this has some number of trials. Don't think so. So this is just 1 cup of coffee, so it's 1. And then A is minus 3 up to 3. So that's going to be 0.3286. Hopefully that's right. So that's going to be option C. All right, so that wraps up multiple choice. That took quite a while to do actually. And yeah, that was with me having already looked through this roughly. So I already know roughly what the answers were and whatnot. So yeah, would have been a struggle in the actual exam unless you're some freak who can do this in like 20 or 30 minutes. Don't know how people would be able to do this in like 30 minutes. That would be pretty quite tough as well. Unless you're just some superhuman, I don't know. So yeah, that's my solutions. If I've made any mistakes, then I'll probably annotate them after I edit this down and whatnot. So yeah, if you do spot any mistakes, then let me know and I'll pin your comments or make some posts in the comment section. But yeah, I'll do section B another time when I have some more time to have a go at the last couple questions. So yeah, that's pretty much all for this video. I hope you guys enjoyed it and found it helpful. And yeah, until the next one, have a wonderful day. And I'll see everyone later. Bye bye.